Today I'm going to talk about attacking backend components, which gets kind of esoteric, and then I have a couple of hands-on demos which show this kind of attack. These attacks get a little convoluted. There are a couple of cross-site scripting based on them. So I got some slides here. All right. So the backend components are the scripts that run on the server that process the data you send there. And there are ways to trick those scripts. So one simple case is the case you had in like the first project in this class, operating system command injection. If you have a way to send up data and the data is used to construct an operating system command, then you get command injection vulnerability. Now here's one done by Perl. They take some data from the user and then they do a du command. This is a website that will let you see how full a directory is, how much the total size of a directory is. So it calculates a du and then it puts in a parameter dir that came from the user. So it creates a command line command and it puts in data from the user without sanitizing it. This is how you cause it. And so now if you put in public, then it will give you the files in the public directory. But if you give it public pipe cat etch password, you can just put another command there and it'll give you the contents of the password file. So this is the same stuff you did before. This is a Perl injection, and HP's OpenView was vulnerable to this with this OVPL thing. Again, you could put in, there was something here called a node that was used in a command, and all you had to do was put a pipe and then another command and it would be injected. These things come by very frequently. All right. And ASP, Microsoft scripting language, can have the same flaw. And I've got a website that does this. I think I might have put it in the 123 class instead of this one where you're injecting it to a Windows server. It's the same story. You have a command that's executed like a directory of a directory name, but this directory name came from the user, so they can inject a second command on the same line and it will execute. So here's a function to list the contents of a directory. So you put in the directory and it shows the contents. And if you put in ampersand ipconfig, then it will give you the contents of the directory and then run ipconfig. So, it's the same old thing. You've done this plenty. All right, and PHP is the one that you did mostly in this class. There's a PHP page. There are different ways to do it. Mine did it with a ping. Here's another thing people do is they use eval. Eval will evaluate a phrase put here, but if that contains data from the user, then it can be used to execute shell commands. So eval is another way to execute a shell command. I mostly use the OS system library, but there are various functions in scripting libraries that execute shell commands, and this is always considered a very poor security practice. You should really not do that. And if you do it, you should really not put any data in there that's controlled by the user, because it's dangerous. So to find these, you inject some special characters and see what happens. The semicolon, the ampersand, and the pipe often connect them. And then there's the backtick. The backtick is kind of crazy. I really don't like it. People like using it. Let me just demonstrate this one live. So if you wanted to, if I wanted to echo hello, that will just echo hello. But I could echo backtick date. As if I echo date, it will just print date. But if I put a backtick around date, it will give me the date. What the backtick means is evaluate this as a separate command and then take the answer and feed it to this command. And people like to use this. Linux people use it all the time. And they love it. I hate it because this character often gets mangled in textbooks and copying and pasting and everything. And also, if I never use it, there's an old-fashioned method I use instead, which you'll see in the projects, which is $ quote. This does the same thing, but I think it's easier to read in instructions and stuff. That's why I always use this one. But anyway, this is the most common one. People like to use this backtick. Real Unix hounds love it. I find it confusing and irritating. Students will confuse it with an apostrophe, and everybody gets a headache. This is a lot nicer in my opinion, but this is the more common thing, that backtick. So that's another thing. If you can inject a backtick, then you might be able to inject a command after it that would be executed. All right, then there's blind command injection, like we're seeing a lot in the Web Security Academy, where you can affect the processing on the server, but there's no answer coming back to you. So it runs, you'll either see no answer or you'll see something like a 500 server error, but you won't actually see the answer. So you can do it just like blind SQL injection. You can inject something that causes a time delay, or you can inject something that has some other effect you can measure, like make a network connection with some kind of networking command, or writes to a file so you can read it. So here's an NSLOOKUP vulnerability. I guess you need an eye up here. There. So this app passed user input to NSLOOKUP, so you could look up an IP address, and it blocked some of these characters, but not all of them. So you couldn't add another command with ampersand or pipe, but you could use a greater than sign. So what you can do then is you can use the greater than sign to point to an executable file. And so you put the server code in the domain name, and what will happen is it'll output this error message in the file. Server can't find code, it will execute this. And so what actually goes in the file, this is by error message, what will be in the error message will be the, well, you go to this file, which will have, it'll print server can't find this, repeating the script code, and then you execute it. So this is a fairly common attack. It often works at log files. You inject code, the code goes into the log, and then you execute the log. So this is one very much like second-order SQL injection, where you would inject a name containing an apostrophe, and when it's used later, then the code would execute. All right. So anyway, to avoid this, don't call commands from your scripting language. If you have to, filter the input with allow listing. Using APIs is better. Avoid taking user data and putting it in something that goes into a command shell. Don't put user data into dynamic execution. If you have to, then filter it with allow listing, so only known good values are permitted. All right, and then of course the file path. Anytime you refer to a file and you can include the path, then you can traverse to an unexpected location. So here's something you see all the time. You have a PHP or ASHX file that then uses a file name. So it's some kind of get file script, and the file name is right there. So if you can put in .. and browse somewhere else, then you can cause this script to operate on a different file than the expected one. All right, so you might be able to read or write to files. This is the most common way that PHP-based websites get hacked. Almost all PHP-based websites seem to have file inclusion vulnerabilities. And then you just find a way to upload a PHP shell and you have control of the box. This is the most common way they get hacked. All right, and you might be able to read sensitive information or overwrite security critical information. So to prevent this, you can run a file system monitoring tool. There are tools, FileMon on Windows, Procmon now, or Tripwire on Linux, or these other ones. These are tools that will just watch to see if any system files have been changed. And you can then observe that you can make a list of suspicious things, and it will raise an alert if the important files have been altered. All right, and you can, so if you want to detect this while doing a pen test, then you just inject a unique string in each submitted parameter, and then filter your file system monitoring tool to see if this appears in a file somewhere. So, if a file is created with that name or a file containing that. So here's a path traversal attack. Up here is a file name, and it's got .. / Windows win.ini, which is just one of those files that's on every Windows machine, or it used to be. And then you can print out the contents of this win.ini file just to show that you can get to a folder that you shouldn't be able to get to. So you try .. and / is a good idea. Either one of them might work. Try URL encoding them. These are good things to get around filters. Try using 16-bit Unicode encoding for these things. That might get past filters. Here's double URL encoding. The %25 is a %, and then the %2e is the dot. So this combination will be interpreted as a dot if it passes through two devices that reverse the URL encoding. And that is fairly common because you'll have like a web application firewall or maybe a proxy and then the server. And there's also overlong UTF-8 encoding. This is why deny listing is such a bad idea. If you're trying to stop slashes, you'd have to take all these kinds of slashes and stop them, which is very difficult. It'd be much better to just allow list things that you know are good and accept nothing else. That's much more effective. So here's, you do these things too. This is how you defeat filters. If it removes one of these .. slashes, it'll have one left over. So there's another way to get around filters. We've talked about that before. And you can use null characters. You can put in a %00, which will terminate the string in C-based code, but not in code based on other languages. So it'll probably be accepted by the web server, but rejected by the web application firewall, and that's one way to get there. So it'll interpret this as an INI file, and then the other part will interpret it as ending in JPEG. So anyway, these are ways to test it. All right. So if you can read things, you can read password files, configuration files, include files that might have database credentials, databases, source code for scripts, and log files. All these are things that are not really supposed to be public, but if you get a file traversal vulnerability, you may be able to read them. And if you can write, of course, then you can change scripts that will run, modify files that will execute commands when a user next connects, write scripts to the web directory, and then call them from your browser. Lots of ways to exploit that. So if you want to prevent these, don't use user-controlled data in any file name or anything else used to make a file name. If you have to take user-controlled data, just allow them to choose from a list of known good inputs, not arbitrary input. And if you want to allow them to submit arbitrary file names, then you'll have to add filters blocking all these things. So after you decode it and remove it from its canonical form, like the percent hex that we use, then after all decoding, then check for forward slashes, backslashes, and null bytes. If you find any of that, stop and reject the request. And in fact, log it as a bad request, a suspicious request, and after you get enough of them, block the IP address. This means they're hacking you. Don't sanitize it and keep using it. Refuse to deal with that. All right. Anyway, these are recommended ways to defend yourself from this. And all right, there's a Java function called getCanonicalPath too, which is nice to get a complete path to an object instead of a relative path that might contain things like .. So you can use the API to make sure that the file name is still in the expected directory and not in some other directory. You can run your app in a chroot jail. This is before there were virtual machines, there were chroot jails. Before there were virtual machines or containers, this is an early version to the same thing. You can define with chroot, you can make the app regard the root of the file system to be in a folder. And now it can only reach things in that folder and it can't get out of that folder. And you have to put every executable it needs in that folder. So it's a little bit like a virtual machine. You have all the apps functionality you need in this little folder, but it's not allowed to ever get out of there. So this was a simple way to protect the other files on your box. You can do it in Windows too. You can map a drive letter to the folder and then access it by that drive letter. Another way to limit your app to only reach inside a certain part of the file system. So include files are very useful. You have an include file with code that you include, like a PHP include, you include in other files. That means you have reused code, and PHP will have an include function that loads that and uses it. And some of them include functions allow remote file paths. So you'll have an include file here that it tries to include your country.php, and you have a whole series of country code files. But if the attacker can inject evil code, if the country came from a parameter like this, then they can inject a remote attacker. So you're trying to include your script from your own server, but because you didn't filter this, they can now load script from some other server, and now it runs. So this is code inclusion. All right, and there's local file inclusion, where even if you can't go to another server, you can still refer to different files on the same box, and this may also be a script you can benefit from. And one common people do is attack default scripts that are there as demonstrations that are insecure. That's a common thing you use. All right, so to find these things, just insert various URLs on the web server you control and see if it tries to fetch it. We put in a non-existent IP address. You'll see a time delay as it times out trying to reach it. And if it's vulnerable, then you put a malicious script on the server and try to fetch it and see if you can execute the malicious script on the box. And so find local file inclusion, try known executable, a known static file, sensitive resources, and traversal to another folder. These are all things you might be able to do. Good, and that's right. Somebody told me they don't have enough volunteers at RSA. I'm glad I reminded this, so you might look into that. You might be able to get a full RSA pass. I think that's, Kim told me that. You get a full RSA pass, and all you have to do is be the monitor for a room. So if you want to go to RSA, that would be a thing to do. You can also, let me mention this while I'm not sure I mentioned it in this class. If you go on my page, RSA is coming up. It's a big security conference in San Francisco, probably worth going to, and you can go to one day of it free, Thursday, by signing up as shown up on this form. So you can go to the Thursday free. But like I say, if you become a volunteer, you can go to the whole thing for free. So those are two options. And it's worth extra credit if you go to it, and you'll get to see some interesting talks and demonstrations and stuff. So it's a good thing to do. All right, let's take a look at a Kahoot. I'll be there on the last day doing a workshop on machine learning, but it's the same kind of stuff you'd see here. Anybody's welcome, but there's not much reason for my students to go to my stuff there, go to other stuff. You guys get plenty of chances to see my stuff. All right. So there we are, 10A. Good, and I see some good chat going by of people talking about how to volunteer and such. Good. Yes, they said they didn't have enough volunteers. They're looking for more. So it's a good opportunity if you want to volunteer and experience RSA. RSA has some good talks and good workshops. I don't really like the demo floor much, with just hundreds of people milling around trying to sell you things, but the talks and workshops are pretty good. And some students really like the demo floor because you can just take a bag and fill it with free stuff. Is that Casey Zerkus at RSA? Somebody just put this in a chat. Yeah, it's in the Twitch chat. Yeah, good. Yep, good. Yeah, volunteering is probably one of the best ways to enjoy the con. It usually is. If you're working with people and helping them, then you make friends and stuff. That's usually more valuable than sitting through a talk. Anyway, same thing for B-Sides. I will be at B-Sides more than RSA. B-Sides is more fun, in my opinion. And B-Sides is the weekend before. And that's another place where it's cheap or free anyway. I highly recommend going to it. I prefer it. So B-Sides here is Saturday and Sunday before RSA. So it's more technical. I prefer it. RSA is more business and management and sales. B-Sides is technical. So that's what I like. They have a good CTF and stuff. Yeah. Godzilla shot. All right. Well, let's do this. Okay, so what defense detects file modification on Linux? And Tripwire is the tool that runs on Linux. I used to have projects where people configured this, and it was very annoying and frustrating to set up. But anyway, it will do that. All right, so which character will perform command execution immediately? The backtick. All right. On Linux, not Windows. All right, so what defense puts the web server in a restricted file system? Ooh, chroot, this thing here, that's a typo to have the same thing here twice. Anyway, chroot is the answer. A chroot jail is the early precursor of containers and virtual machines. Sure, the fancier way to do the same thing. All right, so what vulnerability is caused by eval? Okay, that's command injection, of course. All right. Good, so it's digit cube. I know who that is. Repeat. And Godzilla shot, that'll tell me who they are for upper points. All right. So here's another thing that I've found very screwy at first. You sort of get used to it. So XML, if you have XML services running on your server, which a lot of them do, XML has some features that let you define environment variables, essentially, special macros, essentially, in XML. And you'll see this in things like Ajax, like, for example, Google Maps. In Google Maps, you can drag the map and it fills in the parts that are entering, so it gets little pieces of data with XML, and a lot of things use XML to fetch small amounts of data from a server instead of loading a whole page. And so, to do this, you would send some data. Here's how you do a search in XML. You send a post up to some ASHX script, and then you send it a search term. And here's this XML structured stuff. It looks like HTML. Search term /search term. This is just a way to structure data. All right, and so the server will respond with an XML response. And so you can have XML apps expecting XML formatted data going up and back, which is fine. The problem is it has this ability to define this thing called a doc type. And you can define an entity in here, and this is a shortcut. So you can define a thing called testref, which will stand for this, sort of like a nickname for something. But this can be active and include scripting. So there's the Acunetics, I do an explanation. So if you send a post here, foo hello world /foo, then the server will just echo back what it gets. It interprets that as hello world. So this is normal XML communication. But if you send it a doc type foo, element foo any entity bar world, then you can do hello ampersand bar, and it will fill in bar to be world. So you can define something called bar, which stands for world, and then it will just fill it in. So this would also be pretty harmless, as it is, but where it gets nasty is because you can use active code. So I can define bar to stand for world, and T1 to stand for bar, and T2 to stand for many T1s, and T3 to stand for many T2s. And now, when I print a T3, it's a whole bunch of hello worlds. So this is a simple denial of service attack where you can just create a monstrously large response with a small amount of definitions. And you can also put in code here, like you can define it to refer to the file of its password as an entity called system. And now I defined XXE. Here, XXE stands for system file. And so when you use XXE, it will include the contents of that file. So that's file inclusion. And you can also make HTTP requests. So here it's going to send something to a remote server. And this is going to, as you load this to a remote server. So now the response is going to include this data that came from a different server. So that is local file inclusion. And it's remote file inclusion. It's on a different server. Anyway, so it amounts to the same kind of stuff you've seen with PHP vulnerabilities. All right, and so there's the here's one where the parser will fetch the contents of a remote file and put it in place of the search term. All right, and we've seen that. All right. So you can also connect to an email server. You can connect to something on port 25, and then it will send a request to that port 25. So you can, in principle, use your XML entity injection vulnerable server, XXE, as a bot to probe the network. You can send requests. It's not as good as being able to run Nmap, but you can send some requests and get some responses from servers. So it's one way to use it as a proxy. Then there's denial of service. Here's a simple denial of service. Just make it stand for dev random, which will go on forever. Now, whenever you print it out, it will just print out an infinite long stream of bytes. All right, and then there's another protocol called SOAP, which is Simple Object Access Protocol, which is another XML-based protocol. So here, for example, you'd have a bank where you send this request to a server script, and you send your from account, your amount, your to account, and submit equals submit. So here's the parameters you send. Now, when it gets to the server sends it from one server to another on the back end, and what it does is it creates this with the from account, amount, and to account that came from the user, and then it has somehow decided whether it's okay to make this transfer, like whether you have enough in your balance, and it's added this thing at the server side, cleared funds. So this is false, so this transaction will be rejected. But the problem is the user controlled stuff like this, like the amount and the from account, so they could make an injection here that adds this parameter, which is not supposed to have come from the user. So what you do is here's the normal SOAP message. You inject in the amount, you put in this amount, and then you put close the amount, cleared funds true, to account, and then you start a comment here. And so you send this request with that comment and this, and now here's the SOAP message that will make it. It tries to fill in all that red stuff for the amount, and now it creates a cleared funds. It makes a request. It's automatically cleared, even though the server won't clear it, and you controlled the to account to go to one you injected. So this is the kind of thing you can do. By injecting HTML comments, you can remove part of this, and you can add things that shouldn't be there. So this is the same old injection we talked about before. If you take data and use it to construct a request that goes to another server, you got the same sort of situation as SQL injection. All right. And so you can also just end your injection with an opening comment tag, and that will just remove a bunch of code from the server and might cause interesting consequences. So to find this, just inject some XML meta characters like this, inject a /foo, that should be an unmatched closing tag, and if you don't, that should create an XML error. The parser shouldn't be able to parse it. If there's no error, then your injection is being filtered out. If an error occurs, then inject foo/foo. If the error vanishes, then it is taking your code and it's parsing your code, and now you can try injecting things. All right, so you can inject two values in turn with a closing tag in this and an opening closing thing here, and your reply may include part of this. And this is quite a few of the more advanced Web Security Academy attacks rely on this. You send a request which includes part of another request, which waits in a queue on the server and gets mixed into somebody else's request. This is called HTTP response splitting, and there are several other terms for it. So you can just try injecting an opening comment and a closing comment somewhere else, and that should change. If it's not filtered out, that will remove something from the request and have some unusual effects on the logic. So to prevent this, of course, filter data at every stage. Don't let anybody inject any of these meta characters. Instead, HTML encode them, so they're just printable characters. They're not interpreted as the beginning and ending of tags. All right, and here's some more. You can do server-side HTTP redirection or parameter injection. So if user controllable input is included in a URL, such as here I've got a location. User controls this thing called location that's sent up. And on the server, that location is used somewhere here. I sent up location is online WABlogs, and a backend request. I guess I sent up this IP address, and now it's going to fetch from that. And what it's going to do is, instead of fetching the file from this location, it's going to connect to this server and give me the message the server puts up, the banner from the SSH server. So I'm able to detect an SSH server. That's again using an app as a proxy to connect to other devices to probe them, to see what services are there, and perhaps even deliver attacks. And then there's parameter injection. So here I am sending from account to account and submit, going to the server. And the request from the user causes a backend request. So I send this to the server. The web server then connects to like the database server to see if you have money in the account, creating a request here, including parameters that are under my control. And so if I add an extra parameter called cleared funds equals true, which is not coming from the web form, then that might get passed on to the server. Cleared funds equals true, and it might take effect on the server. So I might be able to set parameters that were not supposed to be under my control. And this comes from the fact that since there are multiple servers, the servers probably don't really know what kind of data should be here and what kind of data should be there. That's why, if you remember the first chapter of this book, they said you have to define security boundaries, and you have to check everything going in and out, each boundary, to see if it is what it should be and it doesn't have added malicious content. And then there's parameter pollution. So suppose I do this. I add cleared funds equals true. Now the server adds cleared funds equals false, as it determines I'm trying to spend money I don't have. The request going to the back end might have two parameters with the same name. Cleared funds equals true and cleared funds equals false. You can set a parameter twice in a request, and if you do, the specifications of HTTP do not say what you should do. So different products do different things. Some of them use just the first one or the last one. Some of them concatenate them together. Some construct an array. So you might be able to set a parameter and it might override the parameter set by the real server logic. So here's the original request, the front end request with the added parameter. When it gets to the server, I'll have cleared funds equals true, and I add cleared funds equals true, and so now the backend request will have cleared fund equals true from me and cleared fund equals false from the server. And some servers will fall for that. All right. So you can also attack the URL translation. URLs are often rewritten to map it to backend functions. We talked about this in template injection, where you have something that looks like folder names, but they're in fact harvested and used as parameters. So that's often done with sort of pattern matching, like grepping, to do it. So here's a rule. We'll rewrite this request. Pub user will rewrite the rule, picking out some contents of this request. It's Apache's mod rewrite. That will take pub user Marcus, and it will turn it into inc user manager.php name equals Marcus. So it's going to pick this out and make it a parameter, and it's going to take the pub user, means have user manager.php. This is the kind of thing we talked about in template injection, where you tell it how to interpret the request and what part of this is the parameter. And therefore, the attack then would be Marcus, and add another parameter here, and there, when I have name equals market, it will add another parameter here. So I can inject a form parameter in what was supposed to be a folder, what appeared to be a folder name or a file name. Apps often send mail for various ways, and if you use SMTP, SMTP is a plain text protocol where you just put in a message and you end it with a line containing a dot. So if I can inject carriage returns and line feeds and dots in, I can change the interpretation of an SMTP request. So here's a feedback form. You can fill in this thing and submit, and it will email a thing. So that would be, this is what it's supposed to do. I give it an email, my email address and a subject. I cannot control the to address, and it will send this comment to the user. But the problem is, if I can inject carriage return line feeds up here, here's a line feed, then I can add a BCC here, and now it'll have an extra line here, and since SMTP is just a plain text protocol like HTTP, it will just accept this BCC. So now I'm sending an extra copy of the email to someone else that the designer did not intend for me to, and therefore I can do even more. I can inject a subject and a message in the from address. And now it'll do mail from, and all this came from the attacker, not from the server. So now I can send whatever I want. And so you can inject a long thing into the subject field, like I can take their form, and I can now send like Viagra spam to somebody from their server. And this is what's commonly done. They find this kind of SMTP injection, then they use your server to send out spam, and your company gets blamed for it. It gets on the blacklists. I've tried warning companies about this, and they didn't care. But anyway, it's here's the resulting spam. So they send something, terminate this one, and then they send an extra email that came from me, not from the user. So now your server is sending spam out to people, and you're getting blamed for it. So to find these things, inject into every parameter, and try various attacks with new lines. New lines are the most important character there, needed for that one. And you validate user supply data. You know, make sure that you don't have new lines in things like email addresses or subjects. And if the contents of a message are being used, don't allow a line containing a single dot, because that would terminate this message and let me add another message below it. All right, so all these are just variations on the command injection we've done before, where data comes in one form and it's interpreted by another server, and you trick the second server into misunderstanding it. All right, so let's try another Kahoot. Remember, this stuff seemed pretty baffling to me when I was new to it. You get used to it by learning these languages. Once you know several languages, then it's easier to understand how things get misunderstood. right, so what attack sets the same value twice? Yep, parameter pollution, they call that. All right, what attack is likely to work on AJAX applications? Yep, because AJAX stands for Asynchronous JavaScript and XML, and it's used to fetch small amounts of data from server with XML HTTP requests. So this is XML-based protocol, and therefore it can be vulnerable to XML external entity injection. All right, what attack injects XML and HTML comments? All right, that's SOAP injection, another XML-based protocol. All right, which attack uses a line containing a single dot? That's SMTP, where the line containing a single dot ends an email message. All right, that's JZ. All right, I'm on that. Oh, good, okay. All right, I'm going to stop that recording.